Hello, folks. So I'm talking about being productive with open source, and that basically means using a full-fledged IDE, means using Eclipse in this case. So it's very opinionated. I already see the eyes rolling, which means I'm saying the right things. So I know there's all sorts of experiences in here. We have hardware people, we have software people. Hopefully you've all at least heard of Eclipse. But if you haven't, I'm going to give a quick overview on what is CDT, and I'm going to show you how to use CDT and how to get started with it, use it a little bit. I've got one of the Vega boards hanging off the side here, so with any luck, I should do, we can do a little bit of a hands-on. If you have the virtual machine already working for you, there's a good chance you can follow along hands-on and do the, import the project, click around a little bit and try it out. If not, JC will kind of go in more detail on that in the afternoon and try to get anyone unstuck who might be stuck. So let's start. What is CDT? Well, basically CDT it's a C++ development environment. It's built on top of Eclipse. It is, it's the main one that everyone in the industry, in the embedded industry, uses. Virtually every company that sells a microcontroller or a CPU has an Eclipse-based CDT offering of a tool set. I've just put a bunch of them up here, so you see you can spot your company, spot your supplier's company. There's an IDE based on CDT for that. So, quick intro who I am. I'm Jonah Graham. I work for Kitcher Coders, which is my company, and we do consulting on C and C++ tools for IDEs. A lot of work these days is going on how do we move into the cloud? How do we get these tools running effectively in the cloud? Can you do software development for embedded tools, but with no tools installed locally? Most of my work has been on working on CDT over the last 5 to 10 years, and an interesting place that's always fun is multi-core debug. So, everyone's trying to get, how do we do debug multi-core better? So it's a fun place to be in. I'm now the Eclipse CDT project lead. For anyone who is familiar with Eclipse CDT, that may be news because for the last about 15 years, a guy named Doug Schaefer here in Ottawa has been the Eclipse CDT lead. He's recently resigned to go work for someone who means I can't work on CDT anymore, which is a real loss to the community, but it's an opportunity for me to step up and have some of these new opportunities going forward. So let's get right in. To use CDT effectively, there is a bit of setup you have to do. CDT has a lot of really advanced features, but to get those to work, you need to create or configure your project so CDT understands your project at a deeper level than just syntax highlighting. So there's kind of like 3 flows to start, depending on where you're coming from. You can import an existing Eclipse project. So someone out there has already went through and set up a project, pointed out the right tool chain, and got it all working. Now, fortunately, the Vega SDK has a whole bunch of these projects in there, and I'll import one of them in a second. Do that, everything's set up, job's done. You can also go through the wizards, the new project wizards, go file, new project, choose all of your options. Now, if the version of Eclipse you has a template for the board that you're targeting or the environment you're targeting, that tends to work very smoothly. If Eclipse doesn't have that your target, there's going to be a bunch of manual configuration that you need to do before you'll be able to get the best out of CDT. Now, this is my opportunity to encourage vendors. If you're shipping Eclipse CDT, make sure you have templates so that users can get going on your board with that, like say the 3-click rule. Start Eclipse, 3 clicks, you should be able to create a project and run on the board. And then the third way to do it is, either you're working in a team where some people don't want to use Eclipse and want to use something else, or you're finally migrating to Eclipse and you're ready to take it on board. So you might want to convert an existing project so that Eclipse understands it, add that bit of metadata so Eclipse can understand your project and be able to get all the value from it. So there's a bunch of GUIs for configuring Eclipse. So for example, you can go into an individual project and say, well, this is the specific tool chain I'm using. So within your VM, you have the RISC v32 unknown ELF based tool chain. So in this project, I've gone and said, let's use that tool chain, and it's going to say, everything, the compiler, obj copy, everything like that. Use the one that starts with that prefix, and in the specific path. And so you go through. There's a lot of different places to configure these things. So I think JC might be going through some of that if you're going from scratch. If you have the VM, this will be set up for you automatically, be pointing at all your tool chains. So this is where I'm going to go into Eclipse and do the live demo part, which you can follow along on. So if you haven't already, you can start up your VM, and you can start up Eclipse. I'll give you a moment to do that. I know some people already have Eclipse running, or at least have the VM running. So if anyone wants me to slow down, say, hey, I want to do it, then. So I don't have the VM on my machine, so I'm not running off the VM, but I can start up Eclipse again. So once you start up into your VM, you've SSH'd in. You can just type Eclipse and run it on the command line. For me, everything's in the RISC-V directory because I don't just do this. So start up Eclipse. It will launch up. Choose a workspace. For the VM, it's totally fine. Just go with the default. As you get more experience, you can have multiple workspaces. The workspace just collects all of your active projects together. And if you have multiple different sets of active projects, you can have multiple workspaces. So once Eclipse is launched, we're going to import some projects. So one really nice way to do it is go to the File menu, choose Open Projects from your file system, and choose a directory. So I have this one pre-typed, but for you it'll be Home, User, RV something, Boards, Demo Apps, and it will search that whole directory structure, finding all the projects in there, and you can choose which ones you want to import. So I'm going to choose none of these ones at the moment, and I'm going to go down there and I'm going to find the Hello World one, for example. So here's the Hello World one for RISC-V Eclipse. Press Finish. And along with the other projects I already have imported, I now have my Hello World project.
Sorry, just
yes.
Exited
Yeah, that's okay. So yeah, it'll be Home, User something. Forgot if someone knows what it is, they can shout out the path. So it should be something like home user, something here. So this is RV something.
I have RV something. Which of the RVs is it?
Let me just. Hello World for RISC.
This one, Risky?
Risky.
Okay.
So once you put you can just go to the you can go to the root and just have an awful lot of things. So I'll just do that because that's what this guy had over here. So have in the Vega directory, you get all the projects in there, and if you just find in there the Hello World, Risky, uncheck everything else and just choose that one. So then you can press Finish and you should have the project. Just looking around to see who's still active, and there's a few people, so I'll give it another minute. If there's anyone who can't quite figure out what the right directory is, put your hand up. I can come over and have a look.
take a while to like load everything in?
It depends if you chose all the projects or just that one.
Oh, shoot. That makes sense.
It will take a bit longer if you import all the projects, as expected. You can delete them all. All right. So I'm going to just continue. If you're having some problems, JC is going to go through some of this in the afternoon as well. So once you do have your project imported, the idea is to then build it. We'll come back to that shortly. But I want to just kind of go through some of the other stuff I showed in that GUI. So I have this other project over here. You have it on your computer as well. It's in the RISC-V OVP Sim directory. So the Imperis tools has the Imperis RISC-V model has a bunch of example programs. So I've imported the Drystone one here, and it doesn't have any way to build it in here. It's just the precompiled executables and the simulation models. By default, when you open that up, you're going to get some errors. And in this case, I can fix those errors by going in here and setting my toolchain settings. So this is where I'd say, well, actually, I want to use the RISC-V 32 unknown ELF toolchain instead of the RISC none embedded toolchain, for example. You don't need to see that one particularly. So we'll come back to building that project soon. But these are the GUIs you might want to be configuring. So for the SDK projects within the VM, you shouldn't have to do any extra configuring today. So hopefully that will be nice and smooth. All right. So if you do have a project that is a bit broken, when you import it, what you end up with is warnings and errors all over the place. You'll end up, Eclipse is going to go, where's std.io? Now, if you've done any C programming, std.io is pretty standard. You expect it to be able to find it. So by getting that configuration right, you have all these errors go away. So one place is you can start browsing all your includes, because now Eclipse will know all your includes are. Your warning markers, your error markers in the editor will go away, and your errors and the problems view will go away, which is a good sign that your project is well configured. So the point of having that bit of overhead at the beginning to get everything configured is to get all of the value of having a fully integrated environment here. So Eclipse has a very feature-rich editor. It's a lot more than just a syntax highlighter. It's more than just a simple command completion. CDT has in it what's called an index. What it does is it parses all of your project code, all your includes. It knows where everything is and it has an in-memory view of your whole project. By having that, that's how you can enable all the advanced functionality, like jumping to definition, auto-completion, call hierarchy, getting outlines of your code, and more powerful things like refactoring, like doing renames across your whole workspace and stuff. Because of the power of this one kind of neat little thing that you can build on top of that is a macro expansion. So if you've been doing any C development in your life, you will have come across a C macro that is written quite simply, but actually expands to some horribly complicated something. So if you have the project installed, you can follow along with this. So I am going to go in and open just a file to edit, because I want to put this line of code with a big macro in it. And the line is this one here, LED1 init. Oops. And then I wanted to do logic LED off. Logic, and LED off. Now, if we look at these are some macros, and the macros have macros in them, so they're pretty complicated. If we hover over here, Eclipse will immediately tell us what the expansion is. This is without compiling. This is what Eclipse is understanding from its own index. And it allows us to get more information. If we just press F2 here, it gives us, allows us to step through the macro expansion. In this case, it's pretty small. It's pretty small here, but in that blue bar it says 10 steps. There's actually 10 layers of macros to get to the final result. And by using the alt left and right arrows, you can cycle through that and see each step expand. So on the left-hand side, you have the unexpanded on that step. What the top part is the expansion, the right side is it expanding. So this is just one of these neat little features within CDT that adds that power that you're not going to get in the same way from your command line tools or your less clever editors. So we've edited the project, we've navigated, we know what's in there. So what we want to do is we want to build the project. Now, CDT will constantly be automatically analyzing your project. So as you're typing, you're going to get some warnings and some errors on the stuff that it's identifying. And when you build the project, then GCC is going to come in and add its opinion and its errors as well. So in this example I have here, you right-click on a project, you press build, or you have it doing it automatically, and GCC is running, and at the bottom there, you get your GCC output. The lines that CDT find interesting get highlighted and get cross-referenced back to your source. So that this line here with 175 on it says, line 175, you have an error, and you can click on there and jump back into your source. This error is quite simple. I type qprintf instead of printf. So we can go and build that project we imported earlier. So if one way to do it is if we right-click on that Hello World project, and we can choose Build Project, and then over here in the console, we can see all of the GCC invocations that are running. And if you look near, they're all pretty much the same, but if you look near the last one, you'll see that's where it's linking it all together into an executable. Now, once it's built, that executable will appear here in this virtual directory called binaries. So we now have an executable that we can download and run to the board, which will come to soon. I'll show you how to do what happens if there's an error as well. So if we build this project now, we should get an error on that line. So we get an error on that line. If we double click on that line, we're going to jump right into what the error is. And all the errors get collected up in the problems view, so they all show up in here. If anyone who's still following along is trying to build a project still, let me know and I can slow down. If you have a question about building the project, now's a good time to ask. Okay.
So you put the
Yep.
line in board.c?
Yeah, I put the what, sorry?
Where did you put that line?
Oh, I stuck in board.c. I don't know what the right place for it is.
You just put in the
Just for the point of doing this example.
Okay.
It was an LED and that was a board, and it said init debug console as a method name, so it wasn't necessarily the best place for it from a software engineering perspective, but I'm not sure. I don't quite know the full layout of how the SDK is. This has a specific project layout that might be that it is opinionated. So actually, I'd probably just delete that line of code now. So later I don't have that problem. So if you've added it, you can delete it as well. I'll build the project again, and my build should now successfully run. All right. So as I mentioned, when you guys successfully build project, a couple of indicators that you have a nicely built project. One is you have binaries. That means you have your actual executable you can run. And the build will finish, and hopefully it'll say 0 errors if you have no errors. All right. So next step, debugging and running. So with CDT, the idea is you can target whatever your environment is. It might be developing for the host computer, for Windows or for Linux, more likely. In this environment, we care about targeting a board or a simulator. So we have the Vega board here. The other thing that we have in the VM is the RISC-V OVP simulation model. So I can show you how to target both of those. So you can run against a simulator. You can run against the actual board, and where it matters, you can compare the two. So what CDT is providing you really, it's a high-level interface to GDB. Now, if you don't know what GDB is the main debugger that's used to communicate with a board and debug with a board. GDB will normally sit on top of something called like OpenOCD or Sega J-Link or whatever other proprietary debug adapter that you might have. So we'll be using OpenOCD today, built on top, running on the J-Link, connecting to the J-Link. That's for the board. For OVP Sim, when you run OVP Sim, it actually provides that debug adapter, so GDB actually connects directly to the simulator, and you can connect that way. So that's what that picture's showing here. You have the executable is run on the simulator, and the simulator talks with the debugger over the RSP port. So the CDT has a whole bunch of views. If you've ever debugged anything, whether it's System Verilog or C, you'll be used to having variables, breakpoints, maybe expressions, hovers. So all that standard stuff is there with CDT. When you come to doing embedded development, there's a couple of extra views which are really useful. Disassembly, if eventually you're going to want to know what did your software actually turn into, and why has it gone wrong at the assembly level. So there's a nice little disassembly view within CDT. One of the nice features I particularly like about it is it has this little gradient. So as you're stepping through, it highlights not the line you're on, but the last few lines you're on. Because often when you get into assembly, you're going pretty quick, and you want to say, hey, I jumped around. What are the last few lines? So it'll show you the line you're on will come in as dark green. That's the next line will execute when you hit step again. And then it'll get lighter and lighter the older in time that the line was executed. So here you can see the lines were, that one was done 3 cycles ago, 2 cycles ago, steps ago, sorry. And then this one's about to be executed. Another really important feature when you get into embedded is you tend to care a lot more about your memory layout and what's where, especially when you're quite resource constrained. So the memory browser within Eclipse has some really nice features. So at a basic level, the memory browser is going to show you what the memory is. You can interpret it in different ways. If you're looking at a block of data that has floating point, you can put floating point on. A lot of vendors have their own visualizations. So some people have visualizations for doing charting and showing pictures. So if you say, I know my bitmap is at this address, you can pull that bitmap up there and it'll actually draw the bitmap for you. But this particular feature I want to show you is annotations. So when you have just this memory view open, it's highlighting a bunch of addresses there and it's putting a name next to them. In this case, what it's showing me is those purple ones are your variables in your code. It says this is where your variable on your stack is actually located. The black ones are showing you the registers. So in this case, RSP on this device, which I think was x86, was pointing at the stack pointer. So here I'm actually having a look at my stack, and it's highlighting where in my stack the different variables are within the stack. So the last part when you're doing debugging and running is there's a whole bunch of other tools that kind of have to come in here. You might have to launch some tools manually, like I'll show with OVP Simulator. You might want to connect a serial port. You might want to interact with GDB directly, especially if you're already quite experienced with GDB. GDB has a lot of power at the command line. So Eclipse comes with a bunch of integrated terminals so that all of your interaction can happen in one place. So the first one to talk about is the debugger console view. So if you open the debugger console view, you're then going to be interacting directly with GDB, and all of your normal GDB commands will just work in there, including command completion, history, and stuff like that. In addition, if you want to connect to a target, so for example, we want to have a serial port connection here, you can use a terminal view to connect to serial target. In the screenshot, I have it connecting to that board, showing it running the RTC demo. You can start a telnet session or SSH session. So when you're running OpenOCD, it creates a telnet port, so you can control your board. So some higher level functions, they board like resetting, things like that. So you can telnet right from within Eclipse. You don't need to leave it. And if you just have to run a third-party command, whatever, something that no one has integrated into Eclipse yet, you can just start a terminal on your machine and get a bash terminal, for example. So I'm going to go through and do some debugging and running here of some projects. If you've imported your project, you will automatically get what's called a launch configuration. Now, before we talked about the project configuration, that tells how to build the project and get your ELF file. The launch configuration says how do you take your ELF file and get it onto a board and run it. So the SDK includes all of the launch configurations for their projects. So if I open up the RTC one or the Hello World one, it's got the name of the project, and then it's going to do run in debug mode using OpenOCD. And I did that a bit quick, so you might have missed where I clicked. So up in here, near the top, there's like the little bug. Press the little down arrow. I can choose debug configurations, or right strictly from the menu, press run and choose debug configurations. That's how we got into this GUI. So within here, it has all the control of how to talk to the debugger. So first thing is, it says what the ELF file we're going to download is. So this is all pre-configured for you in this case. Then it's going to have all the information about connecting to the debugger. So in this case, we're going to start OpenOCD. So here's all the configuration for actually running up OpenOCD. It's going to say, how does GDB connect to it? Where's that telnet port I mentioned earlier? And also, OpenOCD needs to know about the configuration of the board. So this is where the OpenOCD configuration is. Then it's going to start GDB. So GDB is specified here. And there's a number of commands in this case to help GDB start up properly. One really important one that will come valuable as you come along is that these boards have a limited number of hardware breakpoints. So if you tell GDB how many hardware breakpoints there are, the tools will help let you know when you've exceeded that a bit better. You have extra stuff that you can do when you start up and you stop. So for example, when we start up, we want to reset and halt the board. You might want to just connect to a board that's running. In that case, you might not want to reset and halt. You might want to say, I've had this board running for 3 days, it's now crashed. Well, last thing you want to do is press reset on that. You're going to want to connect to that board, find out what the current state of it is, and proceed from there. So this is where you configure that kind of settings. So once you have it all set up properly, you have it all set up properly as it is, press debug, and it's saying, hey, you're doing debugging. You want to go over to the debug perspective. So you get all your debug views. So I'll switch over to that. In the console, you can see that OpenOCD is run. If you've looked at OpenOCD open before, this might look familiar, but it's basically telling you it's connecting to the board with all those settings. Over here, I have my debugger console. So this is where I can interact with it. So I can say print main, and it will tell me that's the main and that's the address it's at. And because we're going to be doing some actual serial connections here, I'm just going to create a serial port so we can actually interact with the little RTC program that we're running. So if I open up a terminal, I can choose the serial port. It's probably going to be that one. It might be different on your machine. And press OK. And now we're connected. So as we run the program, we should start seeing the output there. So we can step through our program. So I'm just pressing the step over button, step over each of all the initializations. Once you get advanced, you can press F6 and go through it. So we're initializing all of our variables, and eventually we're going to start printing something out, which is really what I want to show you here. So the RTC demo is now running, and we have all the interaction. So we had a variable called date over here. Now we have something more interesting to print. So if we say print date, it's going to print out the contents of that date variable we set up before. So if we can set up a breakpoint. So let's see if we set a breakpoint. So if the person says, so if you haven't seen this RTC program before, you probably haven't. Sorry, All right, so when the RTC program runs, it's giving you a little menu, and it's asking you, press 1 to get the current date, press 2 to set the date, and a couple other things. So if I press 1 here, then we'll stop at the breakpoint, sort of as I hope you'd expect, and then I can continue running from within that point. I think that's what to show you within there. All right, so I would just like to show you how to run the OVP simulator, which is sort of similar, but there's a bit more manual setup because the part that's included in your machine doesn't have the tool set that actually launches OVP automatically for you. You can get that from Imperis as a free extra, but you have to register with that first. So I'll do it the manual way. So I've imported this Drystone project, and to run any of these tools, you run the scripts. So we're going to run the RV32 Drystone example, and we're going to say we want to debug it. So we're going to create the port to connect to. So we'll say -port 1234, and when we press run, we can see here that OVP has started up, and it's waiting for a remote debugger to connect. So now what we want to do is connect to that remote debugger. Now I've already set this up, but what you want to do is create a remote application, tell it what the ELF file is, and I've said this is the debugger that I want to use to connect to it. I want to use the RISC-V one. I hope that doesn't happen again. So I press debug in there, and now we're running the Drystone example. So we should see a printf here. So now we're seeing the output of that, and now we have a full RISC-V environment, but no hardware involved. All right, so I'll leave that. I'll just leave that running. All right, so that's all the different integrations that we have in there. So in conclusion, we've gone through quite a lot of stuff today. If you haven't used Eclipse, if you haven't done CT, and certainly if you haven't done software development before, I'm sorry that probably a lot of this kind of went over your head, and I hope that what's done is giving you a little flavor that these flows exist in here somewhere, and that will help you to reach out and say, hey, I saw this thing. I know that this thing might be possible. Let me get in touch with someone who might know how to do it. So say thank you. This is how to get in touch, either with me personally or with various parts of the CDT community, and get you some more help on how to use CDT. And if you're actually shipping RISC-V chips, you probably want to be shipping full sets of tools, including a nice GUI environment, so that your end users can just get started using your chips in like 3 clicks without wasting any time. Thank you very much. And if there's any questions now, you can ask or not. All right, thank you. All right, so the question is, okay, so I said, if you're a commercial company and you're planning to make millions of dollars, you should have Eclipse support. What do you do if you're a smaller, maybe a student-led project, maybe for school for a class? It's a good project for a student to create. Some basic support to put in a simple hello world, new project wizard, get those tools configured right. There's a lot of open source that you're building on top of. What you want is that last step that says, well, actually, instead of all these millions of configuration options, let's have that new project wizard configure the project for my specific tool set. So for example, you may say, you're delivering a RISC-V, maybe an FPGA for your students to use. We say, well, this is the tool chain that we want you to use. If this particular prefix, this is where it is, you can add that in quite straightforwardly. It's something that should be well within the capability of having a master's student do it as a project in the summer, so that the undergrads in the autumn can come and use it, no problem. So, any other questions? Okay, thank you very much. I'll be right over and have a look.